Well, hi, good morning, and thank you for joining me in my shop. Today is the 8th of April. It's Ellipse Day. A lot of excitement here where I live. Now, I live outside of the central track, or the total darkness, I guess, the total darkness band. I live quite a ways away from that. And I'm not traveling down there because the weather forecast today isn't very good, in fact. Right now, the sun is shining brightly right now, but clouds are in the forecast, unfortunately. Well, I just wanted to remind everybody what this radio looks like. Wow. Okay, so where are we at now? So, when I saw the diode in the radio, kind of the first thing I thought, and I've seen this before, is somebody was trying to replace, bypass, or provide an alternate way of the power supply rectifying high voltage. So that's the high voltage rectifier there. And that's kind of what I thought. I made up this diagram. I couldn't see how it would be doing that. It couldn't see. It's kind of in series with the. I couldn't really sort it out. I don't think I've got the wiring down correctly yet. In order to kind of put money where my mouth is, I guess, I decided to cut the lead on the diode. At that time, my thinking was the diode had been installed incorrectly and wasn't performing a function. The tube is sitting here. I mean, if you're going to replace this tube with a diode, you have another problem that shows up. But the first problem is, well, you don't need this tube in here anymore, but you need a heater in this position, or a resistor performing the function of the heater in this tube. You can't just pull the tube out. There'll be no current flow for the heaters. Current flow for the heaters. So this radio came with a resistive cord. It's not a very common thing, but it was done, obviously. The resistive cord's been replaced by an ordinary non-resistive cord. So that presents a problem now. The radio's going to run with an extra 15, 20 volts, I don't know, some significantly higher voltage. That's going to cause everything to run harder, heavier, faster, higher, all that kind of stuff. Obviously the resistor cord was there for a reason. There's a reason to drop the voltage down. And what would that reason really be? Well, two kinds of voltages would go a little out of control with an extra supply voltage. One would be the voltage on the heater of every tube. Every tube would get another volt or so. I guess these ones with the higher voltage filaments would get a few extra volts. And ultimately, you're pushing more current through the heaters. They're all running a little bit hotter. They're all wearing out that much faster, I guess would be the case. So that's one problem. Heaters running too high. The other problem is B plus going too high. So how high is too high? A radio like this would normally produce around 110, 120 volts of B plus, maybe a bit higher. This one's got 130 volts of B plus. Is that a serious thing? Well, the difference between 110 and 130 is not really all that great. I don't think so. Now, what about the extra current going through the tubes? So I think that is the problem with the situation. That is why it had a resistive cord. A resistive cord, the intention of the resistive cord was to reduce the amount of current flowing through these tubes. Why'd they do that? I think if you add up the tube voltages, you got 50 here, and then you got 6, 6, and 6. So that's 18, that's another 20. That's only 70 volts. So the tubes themselves can only drop 70 volts. In a 5-tube radio like this, normally they drop all 120 volts, because the output tube will be a 50 instead of a 25, and the rectifier might be a 35 instead of a 25. It's maybe at that point in time, there were not a set of tubes. Like, all these tubes have to operate with the same current flowing through the filament. It's the same current. They're in series. So they're all got the same current. So they've all got to be designed for the same current. Could be different voltages, different supply voltages. But the engineers designing this would have had to pick tubes that all operated with the same current. And then you can line them up as long as the voltage adds up to what you're supplying, the voltage will drop in accordance with each tube. And ultimately, they'll all have the same current flowing through them. And 70 volts is a long ways from 120. So in order to get around this, I guess one way is to put a resistor in and mimic the cord. Now, if you're going to do that, the cord is a long thing, so it dissipates its heat over a long area. It doesn't get very warm. Take a resistor, do the same thing with it. The resistor is going to get very hot. In fact, you might need a very large resistor to dissipate that kind of heat. And I was showing a couple earlier just how big these things can get to dissipate the heat. And that's exactly why they use the cord. Right? Heat outside the radio, away from it, and you got to get rid of all this heat somehow. So I don't know. There must have been a lot of arguments back in the day about the wisdom of using a resistive cord. Some radios will put in a ballast tube. This is another tube, looks like a tube, looks like this. But all it has in it is a resistive element. And then that can get plenty hot. All these tubes are getting plenty hot. And you could dissipate the amount of power that you need to dissipate in a special tube. Not this one. So there is another trick here. Something I didn't think of, but I received an email from one of you with an idea in it that I wish I'd thought of it a little earlier. I would have been looking for it, and that is to control the current, or get the current back to where it kind of should be. One way might be to use a diode and rectify the power that's going through the tube heaters. So the benefit of this is, well, you cut it to half right away. So if there's a little more, then you cut it in half. You're probably down. You're probably under what you really need flowing through the tubes. In other words, putting a diode in there probably will cool the tubes off too much. I don't know. It's an interesting question. But the thing about the diode is it won't produce heat or any significant amount of heat in itself. All you're really doing is blocking half the power from ever going in. It's almost as if you're turning the switch on and off, 60 times a second. So half the power never makes it. So half the power does at a slightly higher voltage. Where do you end up? You probably end up with less voltage dropping across these tubes than you really want. Now, I cut the diode open, tested the radio, it didn't work, but I didn't make an observation about the tubes heating up or not. So I'm going to do that. I'm going to start this radio up again. The diode is still cut open in there. We're going to watch and see if the tubes heat up. And then I am going to go and get a cup of coffee. Think about all this. Here we go. So switch is on. The power's not on yet. You can watch the dim bulbs too. No action in the dim bulbs. $116 volts on the radio. These lights didn't come on. Why would they not come on? The lights are also in series with the heaters. Okay, so I see no heater action. I wish I'd observed that. So you know what? The diode is in series with the heaters. I'll bet you that's the case. Along with these lights. Along with these little resistors. And what about that other metal-clad wire resistor in there? Oh my gosh, there's a lot of stuff, but at least thank you very much for the email. I think I'm on the right track now. The diode is controlling current flow through the tubes. Turn the power off, and I'm going to go get a cup of coffee and think a little more about this. I think we're on to something here. Okay, so bearing in mind this is a radio that doesn't work, something is out of sorts with it. Could it be this heater voltage control method that the guy, my previous predecessor, put in here? I think we need to test it, and I think it's pretty simple. I think I'm going to put a oscilloscope on one of the heaters of one of the tubes, maybe the output tube. We'll see what the voltage is, we'll see what kind of waveform it is. Here's what I think has happened. Let me just get a piece of paper here. Or what I think is happening. And this is good. I'm learning some stuff here. I can't say I've ever thought of or heard of anybody using a diode like in this scenario here. Just looking for a pencil with some lead on it. No pencil has lead. Okay, so normally the tubes are fed with regular 60 cycle AC power, like that. So, you know, when you hook a voltmeter up to this, and the voltmeter tells you it's 120 volts, it's telling you 120 volts RMS, root mean square, which is a mathematical formulation. The actual voltage here is not 120. The peak here, from here to here, is 169. Or if I, could I have this wrong? It could be 169 all the way down to here. I don't think so. I think it's 169 here. If you take this, feed it through a resistor, and then measure the heat increase, you'll find out that this wave, which is peaking at 169 volts, produces the very same heat as a direct current of 120 volts. So it so happens that this little calculation, root mean square, gets you to the same thing. So that's why when you stick a voltmeter into an outlet, it says 120 volts. It doesn't say 169. It's calibrated to say 120. It's forced to say 120, even though the peak is 169. So this wave, I gotta say this once again, this alternating current with a peak of 169 volts has the same heating effect as 120 volts DC, which if I drew it in here would look something like that. 120 volts being here. So now there was a line cord on this radio. So in fact the voltage reaching the radio was reduced to something like, I can't draw it, something like that. It's somehow reduced. But the resistive cord is gone. So we're back to the full voltage being applied to the radio. Now I have a string of tubes here, 5 of them in there. Okay, there's 3 of them. And they have heaters. Yeah, there's 5 of them. 5 heaters. And with the resistive cord, because one is 50, I'm sorry, that's not 50, 25, 25, and then 6, 6, and 6. This only adds to 70, but there's 120 volts coming in. How much you want to bet that cord reduced 120 to 70? Okay, but it wouldn't be 70 peak. It would be 70 RMS. So it'd be a little more than 70. Now, what happens if you stick a diode in there? So you stick a diode in there, current can only flow in one direction, can't flow in the other. So this all disappears, and you end up with something like this going through the heaters. Something like this. Okay, the peak here is going to be slightly below 169. I hope I got this number right, 169. But it'll be a little less than 169 because the diode does drop a wee bit. So we get 169 here. With the cord in place, this isn't 169. This is, I don't know what. Let's just put it at 110. I don't know what number to write here. Something less than 160, 170. So we've done away with the cord. This has gone up, but then you're doing away with this half. It's gone away. So the question is, what is the heating equivalent of this when compared to the reduced voltage full sine wave? Now the full voltage half wave compared to the reduced voltage sine wave. That's kind of a way of putting it. Is it the same heating in the end? As far as I know, the guy didn't put any resistors in or anything else. He just put a diode, chopped half of it off. So you chop half of it off, but it's actually bigger, so you end up with more than half. I don't know. Is this correct? Is this the cause of why this radio won't work? The tubes aren't getting hot enough? It's a fat chance on that. I don't believe that. Okay, so we're going to want to make a few tests and see what kind of voltages are appearing. Now, if I try to use this meter, it's baloney. It's a baloney. This meter is calibrated for a nice sine wave coming through it. It's not calibrated for a half wave. So we can't read the voltage with this meter. I gotta take the, I can't remember what these clips are on there. Where are they on? They're right across the power supply. Okay, well that's of interest too, but we're not gonna look at that right now. What we want to look at is the heater voltage on at least one of these tubes that I can easily get these clip leads onto. So yeah, which one would that be? Probably better on just check the output tube in particular. Okay, so I'm going to figure out how to clip these clips onto the heater lines of the output tube, and then we're going to look at this on my oscilloscope. Gotta think about that. I don't know if it's just me or it's just everybody. I have had a really hard time seeing this area here until I did this little mental experiment. I took this and all this and all this, and I kind of just flipped it over to here on the diagram in my head and moved it all out. And as soon as you move it all out, you can see quite clearly the rectifier is just attached to the plug. The other side of the incoming power is going to the chassis. You can see it very, very clearly. And then this resistor, if you just follow, the circuit, it comes through all these tube filaments, through this schmozzle of resistors and lights, through the long power cord. This is now a diode sitting here, and then back over. Those are two completely isolated circuits. The heater light bulb circuit is completely separate from the circuit operating, working through the rectifier and then operating the radio. It's completely separate. And it's just because of the way they have it drawn here, my eye has been going around in circles trying to piece this in. Okay, so that being the case now, and we also look at the cord here, and I'm not as familiar with these resistive cords as I am now. There's 3 wires in the cord, not 2. So it looks like 2, but that's because one wire showing this way and the other one is jointed here and split into 2 wires. And again, just my eye just couldn't resolve this in my head. And I don't know, is that just me? I don't think so. So now I have it straight. Okay, 2 totally separate circuits, one running the heaters and the light bulbs with a dropping thing in here, and the other one, the line is attached directly to the rectifier, and you're going to get maximum output here. This means the diode, the cord resistor, has no bearing on the voltage developed, the B plus voltage developed here. Sorry, my mouse is so jerky here. Not exactly sure what goes wrong with it, but here, it won't be jerky here. So, a simple matter now is finding out what's really happening with these tubes. Are they getting their right voltage? So, I can pick almost any test point. If I knew where it is, I can calculate what the voltage should be, and I can test it and see what it is. I'm really just going here is really the best place, right at the start. And that would be right off of one of these light bulb resistors, which is right up on top. So I can easily test this point. I can test this point and test this point. One is going to give me 120 volts, and the other one's going to give me the voltage dropping across this string, which should be 25, 25, and 18 for 68 volts. That's what it should be here. Okay, well, so we can test this and see. Oh, wait a minute. We can't test it because my voltmeter won't read accurately when I'm testing a rectified voltage. I'm going to have to do this with the oscilloscope. Problem with the oscilloscope is it has a ground. So I want to be a little careful. I just put it on the chassis. Yeah, you know what? Just to the chassis and then voltage here. It's easy with the scope. As long as I don't plug this in the wall, you know, regular grounded outlet, I should be okay. Famous last words. Okay, let's so I'm just a little bit anxious, shouldn't be, about connecting this ground to the chassis. I really shouldn't be. The radio's plugged into an isolation transformer, so shouldn't be a problem. But I am such a chicken here, and there have been times in my life where I've been absolutely sure and then turned out to be wrong. So faith, not a good thing. Don't have faith. Here we go. So we're going to see something like half of 120. That's not particularly a bad thing. Radio's switched on. This is an isolation transformer. Okay, we're going to... No, I can't turn on the power. I forgot. I have to solder that diode back. Duh. Forgot. Okay, ready for another attempt. Radio's turned on. Power coming over. Lights are on pretty bright, eh? Those are pretty darn bright. Pretty bright. Only 98 volts. The tubes are heating up, so as the tubes heat up, these should get a little lower, which they are. They're going down a bit. So I'll bet you these resistors are here just to keep things from going too high for these bulbs during the startup process. Okay, now I'm going to attach this to the chassis. It's a nerve-wracking moment. Yes, I'm in an isolation transformer, but just how much isolation really is there? That much. Okay. Such a chicken. There we go. Okay, the idea is to read here in the hopes that this is a right point. What do I got this set to? Way too sensitive here. 5 volts per division on a DC setting, which won't matter. There you see the shape I was drawing on my piece of paper earlier. It's this thing here. There it is. Okay. Now the voltage here, my scope's quite accurate, so it's about not quite 2.5 divisions. So that would be, it's not very much voltage at all. That's 5, a little over 10 volts there. When I'm looking for, what am I looking for here? I think I'm on the part of the circuit. So I'm aiming for here. It'll give me the voltage drop across all the tubes. But instead I'm getting 10 volts. That sounds more like the voltage drop going the other way. That would sound like the voltage drop across these 2 light bulbs. That makes some sense. 10 volts, they're that bright. Let's poke around here a little more. We go on the other side. Same thing. Same thing. That's a little more. So a little more as I'm going this way. But I sure didn't see the this voltage. I'm looking for 70 volts. So I'm going to have to get right on one of these 2 on this 25Z5 on the heater here, which is supposed to be here. How's this working? Did I read my... So I believe this point right here, on the live end here, this. So by my reckoning, I'm reading this voltage drop. What am I doing wrong here? Oh, you know what? Maybe I've got this set to times 10. Oh yeah, that's what's going on. So I can't. Whoop, wrong control, Jeff. Don't get so excited now. So it's way off the scale here, and I can't make my scope less sensitive. I need a different. Okay, so times 10. Keep that in mind. Okay, we'll put it back to times 10. So this now becomes 5, 10, plus a little bit. So say 12. 12, but then you multiply it by 10. 12 times 10, that's 120. There isn't even 120 volts to find here. It's only 98. Or am I just doing really bad math? What's the matter here? 5 volts per division. 50 volts per division, really. 50, that's 120 volts sitting there, according to that. So in that case, what I've done is I've connected up here. So I need to connect here. Because by connecting up here, I'm getting the whole 120 volts. But I want to connect down here. So it's the other end of the light. So it's the other end of the lights. Doesn't quite. It's not what I would guess, obviously. But let's go over here. Where are you gonna go? I guess I can go there. So now that looks exactly the same. That looks like more, because now it's more than 2 divisions. It's quite a bit more than. So here I've got 2, almost 3 divisions. Don't like using the scope for making measurements like this because it's much easier to get the numbers off of a meter. Okay. It's like the same voltage. How can that be? Can't be the case. Pop now, that was a static discharge from me. I'm surprised I got static electricity in the house. I'm going to go and read both sides of these at the same time. This is on the times 10. So my oscilloscope is what's called dual trace. You can do 2 traces. Speed them up here. I get rid of the flashing that's really distinct on the video. It's tracing one, then it's tracing the other because it only has 1 electron beam. So consequently, it looks kind of poppy here. I wish I could fix that a little bit. So we're going to put one on top of the other and compare them. But I can see already this lower one is a little bit smaller. Now, did anybody just see this meter kind of go up from nowhere? How did that happen? Weird stuff going on here. We are operating the radio with reduced voltage too. Only 100 volts instead of 115. And those lights look about as bright as you would want them to be. So I give it the full voltage. The lights are going to be brighter. The tubes are going to be hotter. Okay, continue with what I'm doing here. Comparing these 2 voltages. So I'm going to bring one down a little bit. Right there. And the other one I'm going to move up on top. there's almost no difference here. There's a tiny difference. That's 120 volts with a tiny difference, so that's probably the voltage dropping through here. But I'm still measuring it at 5, 10, almost 15. It's not 120 volts. What am I saying? I was talking earlier about it's 120 volts RMS. It's 169. So if it were full voltage, this would be 169 volts here. Oh my gosh. What am I doing? What am I doing? I don't know anymore. Trying to convince myself that putting a diode in there is the right thing to do. Putting these resistors on here was to compensate for problems that were developing with these voltages. And then plugging this into an outlet doesn't raise the voltage too much anywhere. But very tricky. How can you tell? Because you're sticking a half wave AC voltage in here, how can you tell the heating effect? I probably calculate it, or just okay. So voltage supplied to the radio is higher, half wave cuts half of it out, and you're left with pretty close to what you really need to operate these tubes. So that's probably where this is at. Everything looks fully bright here. These tubes look properly heated to me, and I'm only at 100 volts on the supply. If I put it up to full, everything's going up. If I try to read the voltage across the heater or something like that, because it's only a half wave, none of my meters are going to give me correct information or useful information unless I do calculations from it. I'm not sure I can do that. Looking on the scope, because you're seeing things as peak, doesn't help much in the end. But it does prove, without a doubt, because of the shape here, that that's what the diode is doing, just what was suggested to me in an email. Still don't understand the resistor. The resistor that's in the radio appears to be, oh, I can see it now. Oh no. This resistor, I guess the diode really just taking the place of this resistor is all it's doing. Really, it's quite simple, in fact. Yeah, it's all quite simple. Yeah, it really kind of is. Oh my gosh, I'm making a big kerfuffle over very little here. So I'm going to stop for a bit and deconfuffle, and then think about what to do next with this radio. Which is it working? Did it start working off in the middle of all this? Nothing. Nothing coming out. Nothing at all. Absolutely nothing. Okay, so I did find touching this made a bit of sound. Used to anyway. Doesn't anymore. And I checked for B+, it was there. In spades, it was 130 volts. I have to go and check the tube voltages next, I think. 2-pin voltages, and look for a tube with no B+ on it or something of that sort. We'll skip there. Won't worry about this for now. Won't worry about the diode. I got an idea what they're doing. I'll just keep operating on a lower input voltage for the whole radio. Keep me in the safe zone while I'm doing this, and maybe along the way somewhere things will come to light, and I'll know what I'm doing. Yeah, coffee time now. So I've been doing a little bit of reading, and I think it's really difficult to get a grip on the heating effect of a half-wave rectified voltage to get it really accurate. So for instance, if I grab my voltmeter and take a reading at the voltage drop on the heater of this tube, it should be 25 volts AC. What am I liable to read on this meter? you know, even if I get a number on that, I don't know what I do with it exactly. So for now, I think the best thing I can say is that, you know, my observation, my eyeball observation, is that it looks like everything's running a little hot, and I'm kind of saving the radio by keeping the voltage low, by keeping the dim bulbs in the circuit. That's the impression I got. Is that correct? I don't know. Now, I suppose I could try to filter the AC that's going through the heaters. That would be a challenge. You'd need a pretty hefty capacitor to do it. A small capacitor wouldn't do it because there's a fair bit of current involved here. You're trying to manipulate a large amount of current with a capacitor. What would that do? Ultimately, it would turn it into an RMS DC voltage equivalent instead of the half-wave peak. Yeah, I know I'm not going to do that. Now, would this cause a hum? So normally the heaters are getting a full sine wave. Now they're just getting half every so often. Would that cause a hum? Or other problems of that sort? I don't know for sure. I could see how it might. The points where the current is cut off by the diode may be nonlinear at that moment, and you get some harmonics too. There could be some harmonic stuff going on. You might hear not a 60 cycle hum, but 120 or something of that sort. Maybe. I don't know. So far we haven't heard anything out of the speaker. And why is that? And why is it different now? Maybe I'm confused because I've done too many radios, but I thought touching this was making a small sound in the speaker, but now it doesn't seem to be the case. The radio is exactly as it was. Well, we could listen to these grids and see what kind of signals are up there. Get my scope lights off and try to see how far through the radio it's operating. Like maybe it's operating all the way to the volume control or something like that. So we could listen to these guys here. We could listen to this one too if I just pop this off. If you pop this off, the whole thing comes apart. No, it won't. It won't come apart. Did I say pop? Pop. There we go. Okay, so what I want to do is listen to this. So I will pull out my signal tracer. So what the proper term for this is called localizing. You're going to localize the problem to some smaller section of the radio that you can focus on. So the first approach is kind of checking as quick as possible. That's why I'm putting my finger here to get a notion of how it's not working. Okay. So we got this antenna wire, which I really don't like this hanging here anymore. I'm just worried I'm not going to spot it. It's going to end up going into some place we don't want it to go, and I won't spot it. So we'll get it out of the way. Okay, so ground will go on the chassis, and then we're just going to go like this, like this, and like this, and we're going to hear it coming out of that speaker over there. And you know what? I think, what are we going to hear? I've got to hook up. I've got to get some kind of signal in here, or we're not going to hear anything. Let's try an actual antenna. We'll try the actual outdoor antenna. Oh, wait a minute. That's a problem. No, it isn't. So this when I hook this onto the chassis, the isolation that I enjoy disappears. The thing is no longer isolated, even though it's in an isolation transformer. And if I'm going to put another ground on, better go in the same place. That's the thinking. And where else would I put it anyway? So this is the incoming signal. I'm going to put the ground like this. Let's let it hang down. And then this we're going to attach with a capacitor. Once again, just because I'm nervous, I'm going to get on the wire here. And we'll be ready to connect it here. Ready to connect the antenna. Okay, practicing again. Radio's on. And we just do that and we hear what we hear. Maybe we will hear a radio station. Antenna's not switched on, so I'm going to stop for a minute. I got to switch the antenna. Finish my coffee. Wow, it's getting cloudier and cloudier on eclipse day. I'm not hopeful that we're going to see much here. I think the eclipse here, did I say this, is about 90% here. If you block 90% of the sun, there's still a lot of sun coming down. So I think it's only going to get kind of dusky here a little bit. But I'm looking forward to it. We're ready to go. We are ready to go here. Let me talk about something else for a minute. That hum is the signal in me. I am a walking antenna, so are you. Radio, waves, audio, sound, all kinds of stuff. You see this little radio here? I was running around my house the other day trying to find some interference. This is a cool little radio. So I'm running around, and I know that this radio has a metal case. It's a pretty rugged radio here. Crapola antenna. Something not right here. Not that it matters. The point is, I'm holding this radio. I am presenting it with noise coming from me. I'm running around the house, and I am a noise source. I'm holding the radio. It's coming up everywhere. If I put the radio down, now demonstration here isn't going to work, of course, because that's how demonstrations go. But I can't hold the radio. Now I've run around my house, not with this radio, but with other radios, but holding them in my hand, looking for the source of noise. Meanwhile, I'm generating a ton of noise. So what I did was I put it on this table here that didn't have a radio. Just like put it on a board, holding it out, and I'm holding the board back here. There you go. The point of that was, you're going to run around your house with a radio trying to find noise sources, and you yourself are the noise source, and you're holding the radio, for crying out loud. You'll never find it. And I think that's what I've been doing for years without realizing it. Now we're ready. Now I've been fully distracted. Okay, we're ready. Here we go. On with the power. Once again, very bright lights because of cold heaters. I think it will eventually burn those lights out. That's what I think. We'll let it warm up. We don't care about the sound coming out of the speaker, but we got to turn right up full blast. We're going to turn it down just a little, maybe about halfway, but I don't think we're going to hear anything. The sound you're going to hear is coming out of this device here. This is the thing that's making the sound. Hey, there is some sound coming out of here. Hey, let's try the antenna test. Hey, that radio's working. Hey, man. See? That's how you fix a radio. Okay, on to the next project. Oops, a little too far. Oh boy, radio's working. Despite me. Oh, you know what? Okay, we'll just do this. All fixed up. Beautiful. It was working the whole time. Yeah, it's 1020. 680. Not the strongest. that's 590 Sports Channel. Let's try the French. Good. So I'm sitting here thinking to myself, well, this radio's probably been working the whole time, and I didn't put an antenna on it until now. It's just been that bundle of junky wire. The antenna I've attached to it provides a strong signal into a radio like this, a fairly strong signal. So, boop, boop, boop. Okay. What have I been doing all this time? Well, I think the fellow who did the work previous to me was a clever guy, probably more experienced than me, knew this trick with the diode to restore the heaters, understood what he was doing quite well, compensated for problems in the light bulbs after doing that by adding some resistors. That's my thought. So a guy who really knew what he was doing, because you cannot replace the line cord with a resistive cord. That's just not. That's not on the list. I'm going to pop the ground off here. See what happens. So a radio with a wire antenna does not have a loop antenna, just a piece of wire. Does need some kind of ground to help it along. This is a ground here. No? Is it not? Whoa, learn something new every day. This is not grounded properly. So this is the ground lead from my signal tracer, and I was sure this was a solid ground to the chassis here. It just goes through a grommet. Can you see the little yellow wire right there? That little yellow wire goes to this green wire, and the green wire is a grounded wire running around in front of all the equipment in my shop. So I make sure all these cases are grounded. This isn't. I'm a little surprised at that. Or did I do something stupid over here? It's this. This is definitely a grounded thing in terms of tied to the power system ground, the third prong, whatever you want to call it. Okay. Well, learn something new every day. Put this back on. If you look at the antenna arrangement, well, that's a pretty complicated deal here, how they've done this. But in any case, you got the antenna, which is the wire. We got a capacitor somewhere in the radio protecting you from getting a shock, touching the wire, and walking around your backyard yelling, "Is it any better? Is it any better?" I'm sure people did that. And then you see this connection here. Oh, to chassis. So one of the selling points, or one of the difficulties in selling radios to people, was the need to attach a ground. This is a big hassle. Putting an antenna up is a hassle enough. A ground, like go out in your backyard, pound a metal stake in the ground. Oh my God. You know, I can hear the wife saying to the husband, "You didn't buy another radio that needs a stupid ground, did you? Aren't there radios that don't need a ground anymore?" And there are. Radios with a loop antenna in particular do not need to be grounded. The loop is producing a signal like this. Doesn't need to be grounded. A radio like this, ground the chassis on a hot chassis radio. Wow, I don't know what to think, to be honest with you. Sometimes the ground connection is sort of made through the power cord back into the back into an outlet. It's where the radio can kind of find a ground that way. I feel like if you don't have a ground, you didn't really explain this. See how the antenna is actually not wire connected to the radio anywhere. There's no wire connecting any of this to this. There's just this transformer transforming energy from one side here to the other side. That's how the signal's getting through. So you have a signal up here. It can't work against anything. It's just floating. If you put a ground here, connect this to Earth. That's what I really want to say. Regardless of this symbol suggests connection to the chassis, but let's just pretend it's actually an Earth ground rod. It could be, if you could find this point in the radio. You could do that. Now the antenna is pumping through to the ground. Before, when you don't have a ground here, the antenna it's nothing to pump into. So when it hooks up the ground, now the antenna can pump up and down. It's pumping through the coil, through this transformer in particular, and on into the radio. So when I disconnect the ground, the antenna cannot pump as well through this transformer. Maybe that's the best way to put it. Now this isn't a ground rod. This is attached to power company ground. But the power coming into this radio is coming in through an isolation transformer. So I'm fearless of putting this ground here. But if I pull this plug out, this is polarized, right? I think this is a polarized plug. If I pull this out, stick it in the outlet, in one case, boom, I think it's a dead short right on the power line having this connected. And the other case, if I flip it around, or the other case is turning it off and on, two different cases. Turn it off, there'll be current flowing through the radio still out this ground. Does that make any sense? Doesn't make any sense. I don't know. I'm lost. I'm totally lost. I've got a radio here with nothing wrong with it, and look at me. I'm just totally beside myself. I need a broken radio. My soul needs. Hey, think about this. Nobody needs crime more than the police. Nobody needs sick people more than doctors. Nobody needs broken cars more than mechanics. Nobody needs broken old radios more than me. People need these broken things. It's kind of a conflict of interest, isn't it? I don't know what I'm doing anymore. I am just totally lost here. What am I to do next with this radio? Okay, now I was playing the radio using a very good outdoor antenna. This is a small loop antenna, tuned loop antenna. We're going to try this and see what the radio will pick up. So right now it has no antenna connected at all, and it's silent. Whoops, we'll go that silent. So we'll attach this antenna. So although it looks like a ground and a live wire, it's really not. There's really no difference between these two. We will see now. I don't know what it is. Can't be that. You know what it could be? It could be my soldering iron here. Nope. Don't know. Don't know what it is. But you can see the signal. So you can get good enough performance. I'm down in my shop here. If I was outside, this would be a lot better, no doubt about it. Or even upstairs, just upstairs. So, what to do about this radio? I don't think I have anything to do. I don't think have I done anything other than spend time confused with it. It supposedly wasn't working. It came with the antenna bundled up with a bunch of tin foil wrapped around it. It's not going to help one bit. Extending the wire out might have helped a bit, but really getting something like this, or the outdoor antenna I was using, can make a big difference on a radio like this. This radio comes with a big danger. We're going to plug it into a regular outlet now. This is an isolated antenna, so we don't have to worry about any grounding right now. I'm going to plug it in, and we're going to do some measurements here. Okay, this is going to be, everything's going to be higher in voltage now. We were running it with about 100 volts, I think. Now it's up even higher. Bulbs are really bright. Where'd the radio go? Did it disappear? No, there it is. No, it's receiving about the same. Okay. Voltage. How dangerous is this radio? Now, this is the way it would be if you plugged it into any outlet. Exactly like this. So we're going to look for chassis voltage to a grounded item. There we are. Nothing. So they say, oh, that's a safe radio. Let me just be absolutely sure I've got it. Doing things right. Fantastic. What a safe radio. Let me just turn it off. Now the moment I turn it off, I'm holding that metal knob. Lucky I am isolated because now this is usually where the demonstration goes totally wrong. It should be on 600, not 60. And remember, I lit a light bulb off this. So that's a real 120 volts. Turn this radio off, and you're ready to get 120 volt shock from it. And that's the situation. And if you wire it the other way, it's just the other way around. Then it's hot when it's on and safe when it's off. Your choice, but you need to know. I think really, you got a radio like this, you better get a voltmeter, and you know, you don't want to be the test voltmeter yourself. You don't want to find out with your hands that the thing is hot. I don't think there's anything I can do to this. I think I should just leave it as it is. The last guy knew what he was doing. He knew better than me. So yeah, when I'm working on these radios and I find something like that, somebody's done a change and it doesn't make sense to me, I'm telling myself all the way along, you're getting it wrong, Jim. I doubt myself first, and you know, usually I'm right. Yeah. Okay. Other than putting it back in its cabinet, I don't know. Oh, yeah, let's put it back in its cabinet. Say farewell. Okay, we're almost ready to operate the radio, but first I want to hook it up to the outdoor antenna. The outdoor antenna is earth grounded, and I want to check for voltage here. So I have it plugged into a regular outlet and the switch is off right now. That should, according to my last test, put 120 volts on here relative to earth. So here we go on earth. Oops. Funny sound there. 66. That's interesting. So when you get half the 120 volts, usually indicates that there was not a solid connection between the chassis and the power, and in fact there's a capacitor involved. That's kind of weird. That's really quite weird, because I was fully expecting to see 120. Now, how did I see 120 before? Okay, let's read it. Let's read it here. I can't imagine this would be any different. 60 again. Nothing's hooked up to the radio. We're going to turn it on. There's so much light, that light comes out the side of the radio. Same thing here. Not a lot coming out down here. How come? Well, that's kind of weird. How come so much light, but not coming out the front? Now those, well, it looks like one bulb. It looks like when I put the radio in and push it forward, the bulbs get pushed back. And it would look like one bulb is actually so far back, the filament is on the wrong side of a plate. The other one looks like it's forward enough. This one looks like it's forward enough. Oh my gosh. There's so much light in there. Surely there's some available out here. Let me turn off my shop lights here and we'll get a look at this thing in the dark. Oh! That's a glowing radio. Look at that. Wow. I don't know. That's going to look. Let me close my door here. Oh boy. Everything is glowing, but the panel face is not glowing very well. But look at this thing. Oh my gosh. I don't know what to do about that. Yeah, I don't think there's anything I can do about that. Wow, that's in a dark room. It looks a little silly actually. Let's put some light on. So you put a little light on, and you don't see any of that. But unfortunately, it's not lighting this front panel well at all. Well, I guess that's something the owner could pull the radio out and monkey around with the lights. But it looks to me like there's little to no room here for the bulb to be lighting the front panel. It's kind of weird. Okay, back to what we were doing now. Now the radio's on. What kind of voltage do we get? It's hoping a 0 at this point. So we get a 0. How do we get the 60 there? We get the 60 because I'm reading it through the radio circuitry. Because the radio circuitry is in series. You didn't see that, did you? So radio switched on. Got my voltmeter. One side grounded. The other side going on the chassis. I see nothing. We turn the radio off. Do the same test. There's the 120. What happened to the 60? What's going on here? Remember, I lit a light bulb off this. This is what I would expect. How did they get 60 there? I don't know. What's on the antenna wire? Look at. Virtually the entire radio is you pretty much touch anything, you'll probably see 120 volts on anything. Even like anything. And we could light a light bulb from that, as I demonstrated before. So my recommendation with a radio like this, where it has a true hot chassis, is either run it off an isolation transformer if you have one, but fat chance on you having one. Only plug it in and operate it. Only plug it in when you're going to play it, otherwise leave it unplugged. When you plug it in, understand that there could be voltage on here. Doesn't even matter if it's a polarized plug. There's no guarantee that there isn't voltage. It could be gone when the switch is one way and there when the switch is the other. And so in terms of hooking up an antenna, hooking up a wire antenna to this, I would say no, that's probably not a good idea, because there's a ground potentially involved, or you're fooling around with this wire outside, and I don't know about that. Instead, I think it would be much better to get a loop antenna like this, and there's various versions of it. This is one that, this is pretty cheap. This is like $50 or something. And then you could hook that up, both wires coming from there, one here and one on the chassis, And caution all the time, only plugging it in when you're going to actually play the radio. Don't touch the chassis under any circumstances. That's probably the bottom line. Well, and that's it for this radio. There's nothing more I can do with it, or should do to it, I don't think. I should unplug it, that's for sure. Next thing you know, I'll be demonstrating the electrocution. I'm going to leave the wire very short here. Son of a gun. I can't really leave it like this. Okay, so I'm gonna put a little extension wire on there, but I won't bother with the video part of it. We're done. It's over. I didn't do anything. I did nothing but get confused by this radio. I did learn something, actually. I learned the diode trick for the replacement. The diode trick to control the current in the heaters of a radio like this when the voltage dropping power cord is gone. Okay. Thanks a lot for watching. See ya.